Hello viewers, my name is Mr. Ntangana from Dalibaso SS. Welcome to ECDoE Broadcast Studio. Today's lesson is about differential calculus. I'll be presenting my topic on this topic, differential calculus. Usually, differential calculus, we just say we want to get the gradient of the function at any point. But let's get to the gradient first. Usually in grade 10, how you calculate the gradient, you use the formula m equals to y2 minus y1 divided by x2 minus x1. That is the formula we're using for calculating the average gradient in grade 10. But in calculus, you will see something like m is equals to f at x2 minus f at x1 divided by x2 minus x1, which is a similar form to the formula above. For example, you'll be asked to calculate the gradient of the function, because I said in differential calculus we are focusing only on the gradient of the function. But if we're talking of the average gradient now of the function, f of x equals to x squared plus 2. Now you'll be given the points at x equals to 1 and at x equals to 2. Now to answer the question, because of the formula above, it says f at x2 minus f at x1 divided by x2 minus x1. So to get the corresponding y values now, we'd have to substitute the x values, which is x equals to 1 and x equals to 2, to get the y values. So if you substitute there, x equals to 1 on that function, f of x equals to x squared plus 2, you will get 3. And then if you substitute 2 on that function, x squared plus 2, you will get a 6. Now, your average gradient now would be, substituting from that formula, f at x2, which is a y value, will be 6 minus 3, or divided by 2 minus 1. And that average gradient will be equals to a 2. But now in calculus, we are interested in finding the gradient at one point. We are finding the gradient at one point. So to get that gradient, we differentiate that function and then we substitute the x value to that function, to the derivative. Now, but how do you differentiate? Now, before we get to that, before we get to differentiation, we can look at the notation first on how do you see a derivative, or how do you differentiate. Now, a notation, if you have a function f of x, its derivative will be f prime of x. So a derivative, we see it by f prime of x. And then if ever you have a function of y, let's say you have y equals to, so the derivative will be written as dy over dx, which means we're differentiating the function of y, but with respect to x. That's the meaning of dy over dx. You are differentiating the function of y with respect to x. Now you can also see something like dx, and then you get an expression. So it means that when you are reading that that question, it would say differentiate x, and then on that expression. But we'll look at that later. Then also you can differentiate expression like this, d over dx, then you put that expression there. So which means that you differentiate an expression with respect to x on that expression. But for deriving, there are certain rules that you would have to follow, which we are going to look at now. There are certain rules that you would have to follow. For instance, for rule 1, because you'll be given a function and you want the gradient of that function at that specific value, because we're interested in getting the gradient at one point, not 2 points now. In calculus, we're getting the gradient at 1 point. So if ever you are given the function of f of x equals to ax to the power n, where a is a constant, then x is a base and n is an exponent. Now to differentiate that function, you would get an, which is you drop the exponent, an base x to the power n minus 1. So that is the first rule you are using when you are differentiating. It's an x to the power n minus 1, where a is a constant. And for rule 2, if ever you are given an expression, differentiate x on that expression ax, because that is not an equation, it's an expression. Differentiate x in that expression ax. Now the derivative of that expression, the answer of that expression will be a, which means if you are differentiating that expression ax, your answer will just be that constant a, which is a similar thing for f of x equals to ax, then the derivative, which is f prime of x, because we see a derivative after we have differentiated, it will be written as f prime of x, it will be equals to a. Remember that it's not always that it will be f of x, it can be g of x, it can be f of x, it can be h of x. So you take note of that. Then f of x is a function, and f prime its derivative will also be a function, and that function will be a gradient, but we'll look into that later. Then for rule 3, which is the third rule of differentiating, if you are differentiating now a constant, which is d over dx, into a, you are differentiating that constant, a derivative of the constant is equals to 0. And I will show you how, when you are looking at the examples, how is the derivative of a constant equals to 0. And then for rule 4, if the variable now to be derived is in the denominator, you need to take note of this one, because that's where the examiners get you. If the variable to be derived is in the denominator or under a root sign, we use laws of exponents to rewrite the expression in the form, to the form ax to the power n before applying rule 1, which means now before you start to differentiate, you must make sure that your expression, your equation, is written in this form ax to the power n before you apply rule 1. So you need to manipulate that set if ever it's under the root sign, or you manipulate that variable if ever it's in the denominator by applying the laws of exponents. And then rule 5, we do not differentiate when there are brackets. So whenever you are differentiating, you must make sure that you remove the brackets first. There must be no brackets. So you remove the brackets. I'm sure you know that one from, it's a grade 8 and 9 work. Also grade 10 is there, how to multiply the brackets. Then let's look at now the differentiation itself. What do I mean by differentiation? Now, when we are differentiating a function, we are saying now we are finding the derivative of that function. So whenever you are differentiating, that's know that the answer is called the derivative, and that process is called differentiation. So when you are differentiating, the process is called differentiation. These are just the keywords that we are going to use in calculus. And then that answer now, which is the derivative, which is the answer you are going to get after you have differentiated, that answer will be a derivative. And we always say that the derivative is equal to the gradient of that function. A derivative is equal to the gradient of the function. So the answer there will actually be a gradient of the function at any point. It will be a gradient of the function at any point. Now, because we are finding a gradient of the function at one point, we can also say that we are finding the gradient of the tangent. I'm sure you remember the word tangent. So a tangent is a line that will touch the graph at one point. So whenever we're differentiating, because we're finding the gradient at one point, we can link that to a tangent. But we'll look into that later on. Then the gradient, we need to note this one, that the gradient of the function is equals to the derivative of that function. So a gradient of the function is equals to a derivative of that function. We can write it like this, that the gradient of the function, so if we're saying f prime of x, that f prime of x is equals to the gradient of that function. So whenever you see f prime of x, just know that it is a gradient of the function at any point. Now if you want the gradient maybe at x equals to 2, I'm making an example, then you would have to substitute that f at 2 would be equals to that gradient. F prime at 2 will be equals to that gradient. So you see here we will be given 1 point, x equals to 2 or x equals to any number. But to get that gradient, you are going to differentiate, and then you substitute the value of x to get the gradient of the function at any point. So at this point now, it will be x equals to 2. But now we can look at just the examples on how you can differentiate. If you look here, example 1, we have determined the examiner will say determine d over dx of 2x squared minus 3x. So you are determining d over dx of 2x squared minus 3x. So before you differentiate, we are going to look at the rules now, the rules that we have mentioned above. Now, is there a radical sign or a root sign? No. Is the variable we are differentiating x on the denominator? No. Are there any brackets there to be removed? No. So if your answer is no to all these questions, you can start differentiating. Now, if we're differentiating that one, if we're differentiating that one, which is d over dx, and then square brackets 2x squared minus 3x. So because now we have ticked all the boxes that now this one is suitable for let me just rub this one. It is suitable to be derived. So you can now start deriving because all the boxes you have ticked, there are no root signs, and there are no brackets to be removed, and also your variable is not on the denominator. So you can start differentiating now. So if you are starting to differentiate, you say now is equals to that differentiation is equals to, now what differentiate, remember the rule that it was saying if ever you are differentiating, you are going to use ax to the power n. So that derivative there, it will be when you are deriving, it will be ax to the power n, then our derivative would be a into n x to the power n minus 1. So remember that rule. That is the first rule for deriving. So if we are deriving here, we can continue to say, and now we have the coefficient, which is a constant. We have a constant there, 2 in 2. Then we are substituting the exponent, n, which in this case is 2, and then into the base, x to the power 2, the exponent minus 1. Then we go to the next term. We are going to differentiate it separately. X to the power 0 is 1. Remember, it's not going to be the whole thing that will be 1, because it's only x that is raised to the power 0. So you take note of that it is only x that is raised to the power 0, not the whole thing. So the coefficient, they will not be affected by that 0. Then your answer will be -3. Then you end there. You get a 2 marks. So this is a 2 marks question when you are marking there. This is 1 mark, 1 mark. You get 2 marks. So it's just an easy one, this one. It was an easy one. It's just basics. Now we can look at example number 2. dy over dx. Determine dy over dx if now your function is y equals to half x minus 2 minus 2. Right. Now you see here, the examiners, they will trick you because they know that when you are scared of the negative exponent. So I put this one on purpose. So we have y equals to half x minus 2, half x to the power minus 2 minus 2. Then we need to differentiate this one. Again, we're looking at the golden rules. Are there any root signs there? No. And then is your base, which is x, what we're going to differentiate on the denominator? And the answer is no. Then are there any brackets there before we start differentiating? No. Then we go on to solve now the equation. We say y equals to half x to the power minus 2 minus 2. And then we can start differentiating now. Well, now when you're starting to differentiate, you need to write that it's dy over dx that was asked there. Determine dy over dx, the question was saying. So if you determine dy over dx, it will be half. Then we are using the rule. It's half, you drop the exponent, minus 2, and then x to the power minus 2 minus 2. Remember now, this one will be 0. The derivative there of a constant, it's a 0. The derivative of a constant is a 0. How is it 0? Because I said I was going to show you later on. It's 0 because if you look at 2, 2 has a base that is x, if you can write it in that case. Remember we said that 2x to the power 0 is 2 because x to the power 0 is a 1. So if you go on there, you differentiate this one, it will be 2 into 0 x, because 2 into 0, 0 minus 1. And then remember that anything that is multiplied by 0 is 0. So 2 times 0 will be equals 2 times 0, x to the power 0 minus 1 will be equals to 0. That's why we're saying now the derivative of this function is a 0. Derivative of 2 is a 0. Let me move this one upwards, yes. Derivative of a constant is 0. So you continue to say there that it will be half into negative 2 x to the power minus 2 minus 0. And the answer, what is the half of negative 2? It's negative 1. So the answer will be negative x to the power minus 2. That will be your final answer. That will be your final answer for that one. Let's look at example number 3. So now you are given a function x, f of x equals to 3x squared over 2 minus 24 root x. 3x squared over 2 minus 24 root x. Now you ask yourself the questions again. Do you see brackets there? And the answer is a no. And then do you see a radical sign? And the answer is a yes, because there is a root x there. So before we differentiate, we need to look at these things. We remove the radical sign. I'll show you how. Now, the question is saying determine the gradient of the function at x equals to a 9. Remember now I said that the gradient of the function at a specific point is equal to the derivative of that function. So which means now we need to derive this function to get that gradient. Now, before we derive, we need to fix there. We can't just say f prime of x when there's still a root there. So if we're fixing that root, remember that in grade 9, which is the laws of exponents, if ever you have n here and ax, let's say just say it will be the root of x to the power m. Now your answer, if you are writing that set in exponential form, it will be x to the power, the exponent of x divided by n. That is how you change the root into an exponent. So we are going to do the same thing here. We are going to do the same thing here when we are solving this one. Before we start to differentiate, it will be f of x equals to 3x squared over 2 minus 24. Remember, we're changing that x. So it will be x to the power exponent of x divided by what we find there on the root, which is 2. So this is a square root, so it's divided by 2 because it's a square root. Now, you can start differentiating now. So if we continue to differentiate there, it will be f of x, f prime of x is equals to, because we're starting to differentiate, 3 into the exponent 2. All of this is divided by 2. Then x to the power 2 minus 1. Let me just move this one to this side, yes. And then you go on to say it's going to be negative 24 into the exponent half of x to the power half minus 1. Yes, then you go on, f prime of x is equals to 3 times 2 is 6. And then 6 divided by 2 is 3. So you get 3x. 2 minus 1 is a 1. We don't write that exponent when it's 1. Then what is a half of negative 12? That is negative 12 times 1. The half of negative 12 is, of negative 24, sorry, it's a 12. And then x to the power half minus 1, it will be negative half. Now, you don't end here because the question was looking for the gradient of that function at that specific point, which is x equals to 9. So to get that gradient there, we know that f prime of x is equals to the gradient of the function. So f prime of x is equals to the gradient of the function. So if we want the gradient now of this function, we just substitute the x value there into the gradient. So f prime of x was equals to 3x minus 12 x to the power negative half equals to m. Then now your m will be equals to, substitute 9, 3 into 9. We want the gradient at x equals to 9 minus 12 into 9 to the power negative half. Then you can press your calculator. If I'm pressing your calculator, it will be 3 into 9 minus 12 into 9 to the power exponent negative 1 over 2 negative, and your answer will be equals to 23. So the gradient there of the function at x equals to 9 is equals to 23. So you see now how you get the gradient at the specific point. You get the derivative first, and then you just need to know that the derivative of the function is equals to the gradient of the function at any point. But in this case, we are given which point, x equals to 9. Then you just substitute there to get the gradient of the function at x equals to 9. I will leave you with number 4 and number 5 so that you do it in your own spare time. You leave your answers in the comment section. So we have come to an end of our lesson. You can leave your questions also on the comments box. Don't forget to leave the name of your school so we can give shout outs. Please share, recommend, and subscribe to our YouTube channel. Thank you for watching. See you on our next lesson on the tangent. Now we're going to look at the tangent to the function.